Good morning to everyone. I am Sweta from GMRP Gachwell. In this video lesson, I am going to discuss about different T-junctions, state the need for isolators, state the need for circulators, and state the need of directional couplers. So, first of all, we will discuss about different types of T-junctions. Okay. So, first of all, what is a T-junction? Okay. So, to combine two or more signals or to split into two or more parts in a waveguide system, waveguide junctions must be used. So, for simpler interconnection, we use T-shaped junctions are used. So, T-junction is nothing but it is used to combine two or more signals or to split two or more parts. Okay. For that purpose, here we are using a junctions that shape is in alphabet T. So, for what is the function of T junction is for simpler interconnections, we use T junctions. Okay. So, here the waveguide T's are used for the purpose of connecting a branch section of waveguide in series or parallel with the main waveguide. So here the T junction is an interconnection of three waveguides in the form of English alphabet T. Okay, so T junction can be it is an interconnection of three waveguides. So that interconnection will be takes place like a letter, that is English alphabet letter T. Okay. So there are basically we have three types of T junctions: H plane T, E plane T, and EH plane T, or hybrid T or magic T. Okay. So these are the T junctions. This is the E plane arm, H plane arm. This is an arm A, arm B. Okay. Next one is state the need for isolators. Okay. So isolator is nothing but it is a device which is non-reciprocal and is used to isolate transmission in one direction and allow transmission in the opposite direction in a transmission line. Okay. So isolator is a device which is non-reciprocal and is used to isolate the transmission in one direction and allow the transmission. Okay. So one direction it is used to isolate the transmission and another direction it allow the transmission in the opposite direction in a transmission line is called as a isolator. So an ideal isolator is supposed to allow the signal without any attenuation in the given direction. So whereas totally cut off the signal transmission in the opposite direction. Only one direction only it will allow and another direction it opposite or oppose the another direction. So but in practice this is not possible and isolators are used to design such that they offer minimal attenuation in the forward direction and very large attenuation in the reverse direction. Okay, only one direction it allows. So whenever the unmatched load is connected to the waveguide, the reflected waves are generated from the load and returned towards the generator at the other end of the waveguide. So due to this, the frequency stability of the generator will be affected. In order to minimize the frequency instability, here we use a isolators. Isolator is a non-reciprocal transmission device that is used to isolate one component in the transmission line. An ideal isolator completely absorbs the power for propagation in one direction and provides lossless transmission in the opposite direction. So thus the isolator is usually called as a uniline. So because of this feature, we call it as a uniline. So here the isolators are generally used to improve the frequency stability of the microwave generators such as klystrons or magnetrons, in which the reflection from the load affects the generating frequency. Okay. So an isolator is thus placed between the generator and the unmatched load. This allows the signal to travel through the isolator with a minimal attenuation from generator to load, while the load reflected, the signal is highly attenuated and the signal reaching the generator in reverse direction is of a very small strength and so will not affect the frequency stability of the microwave generator. Okay, so here this is a microwave source, microwave signal, load. This is a reflected waves. Here the reflected wave goes to microwave generator due to mismatch of the microwave generator output and load. So without using a isolator. So once we use the isolator here, here the reflected waves does not goes to microwave generator output and load using a isolator. So once see here, next need for circulators. So here the circulator is a 4-port microwave device. Okay, it has a property that each terminal is connected only to the next clockwise terminal. So once see here, so port 1 is connected to the port 2 only, but not connected to port 3 and 4, and port 2 is connected to where port 3 only, but not it is connected to port 2 and port 1, etc. So the wave only travels one direction and in the opposite direction. Yes, there is no propagation. The wave travels from nth port, that is nth port to, here the port will travels from nth port to n plus 1th port and not in the opposite direction. That means the signal will be travels from port 1 to port 2 but not port 2 to 1. Okay, in not a reverse direction. So actually microwave circulator is a multi-point microwave device. There is no restriction on the number of ports and has any number of ports depending on the application. 4-port circulators are most commonly used circulators. They are useful in parametric amplifiers, tunnel diodes. They are used in parametric amplifiers, tunnel diodes and microwave links, duplexers in radars. So the main application of the circulator is the isolation of the transmitter and receiver connected to the same antenna. Okay, so in radars and microwave links. So once again we'll discuss. So once see here, circulator Here the microwave circulator is a multi-point or four-port device in which the power is circulated from one port to another port only in one direction only. Here we are considering a four-port circulator which is commonly used. So it is a non-reciprocal component. All the four ports are matched and the transmission of the power takes place in a cyclic order only. That means in a cyclic order only the waves will be propagated. An ideal circulator is a perfectly lossless circulator. So consider, here we are considering a four-port circulator that is connected to the radar system. Here so you can also observe that we have a four ports. Here port 1 is connected to port 2, not port 2, 3 and 4, and port 2 is connected to 3 and 4, not port 2 is connected to 3, not 1 and 4, and so on. So here the microwave circulator is a multi-port microwave device. So they are useful in parametric amplifiers, tunnel diodes, microwave links, duplexers in the radars. Okay. The application of the circulator is the isolation of the transmitter and receiver connected to the same antenna. Okay. So same application once we apply to the radar. So once here in radar also we have to consider same as it is four-port circulator that is connected to the radar system. Here the port, suppose we discuss that port C is connected to the transmitter, whereas the port A is connected to the receiver. A common antenna for transmitter and receiver is connected to port 2. So here we have to connect a one common antenna that is used for both transmitter and receiver. So the transmitted waves from the port 3 are circulated through port 2, which is connected to the antenna, while the received signal from the antenna circulated through the port 1 and gives to the receiver. So the remaining port 4, here we have a remaining port 4 is used for measurement purpose. So in this way a common antenna is used with the help of the circulator. Okay, so this is about circulator. Now coming to the directional coupler. So here the directional couplers are the transmission line devices that couple together two circuits in one direction. Okay, so the purpose of directional coupler is it is used to couple the two circuits in one direction by providing a great degree of isolation in the opposite direction. So it will provide a opposite direction great isolation it will provide. Okay, so a directional coupler is a device used for the measurement of unidirectional power. So it is used for the measurement of unidirectional power, standing wave ratio and unidirectional wavelength. Okay, so the purpose of directional coupler is to measure the unidirectional power, standing wave ratio and unidirectional wavelength. Okay, a directional coupler is a four-port waveguide junction in which the portions of the forward and reverse traveling waves on a lines are separately coupled to two of the ports. Okay. So it consists of a primary waveguide, that is a main waveguide, and a secondary waveguide, that is an auxiliary waveguide. So this is a directional coupler. So this is a directional coupler. It consists of a primary waveguide, that is, so see here, it consists of a primary waveguide, that is a main waveguide, and a secondary waveguide, that is an auxiliary waveguide. So in this, most couplers sample the energy traveling in only in one direction only. However, the directional couplers can be constructed that simple energy in both the directions, so that it is called as a bidirectional couplers, and are widely used in radar and communication systems. In its most common form, the directional coupler consists of a two transmission lines. So see here, two transmission lines and a mechanism for coupling signals between them. Its properties may be summarized with the aid of the schematic diagram with a matched termination of the output ports. So a portion of the wave traveling from port 1 to port 2 is coupled to port 4. Yes, coupled to port 4 but not to port 3. Next, a portion of the wave traveling from port 2 to port 1 is coupled to port 3 but not the port 4. So a portion of the wave incident on the port 3 is coupled to port 2 but not the port 1, and a portion of the wave incident on the port 4 is coupled to port 1 but not the port 2. So this is all about directional coupler. So once again we'll discuss. So different types of T-junctions, need for isolator and need the circulators, need of directional couplers. So first of all, list different types of T-junctions. Actually we have three types of T-junctions. So H-plane T-junction, E-plane T-junction and EH-plane T-junction. Okay. So the function of T-junction is to combine two or more signals or split into two or more chords in a waveguide system. A waveguide junctions must be used for simpler interconnection. T-shaped junctions are used. So here the waveguide T's are used for the purpose of connecting a branch section of waveguide in series or parallel with the main waveguide. So here the T junction is an interconnection of three waveguides in the form of English alphabet T. We have H-plane T junction, E-plane T junction and EH-plane T junction. Okay. Different types of T junctions are there. Next is isolators. So here isolator is a device which is a non-reciprocal and is used to isolate transmission in one direction and allow the transmission in the opposite direction in a transmission line. So the function of isolator is to allow the signal without any attenuation in the given direction. So whereas in other direction, totally cut off the signal in the opposite direction. Only it isolates or it transmits the signal in one direction. So whenever the unmatched load is connected to the waveguide, the reflected waves are generated from the load and, and returned towards the generator at the other end of the waveguide. So due to this, the frequency stability of the generator will be affected. In order to minimize the frequency instability, we use isolators are used. Isolator is a non-reciprocal transmission device that is used to isolate one component in the transmission line. An ideal isolator completely absorbs the power from for a propagation in one direction and provides the lossless transmission in the opposite direction. So thus the isolator is usually called as a uniline. Isolators are generally used to improve the frequency stability of the microwave generators such as klystons or magnetrons, in which the reflection from the load will affect the generating frequency. Circulators. So this is a reflected waves goes to microwave generator due to mismatch of the input and output. But here reflected waves does not go to microwave generator output and load, but because here we are using a isolator. Next, need for the circulator. So here the circulator is a multi-port device in which the power is circulated from one port to another port only in one direction. A 4-port circulator is most commonly used. So here we are using a 4-port circulator that is commonly used circulator. So in this, it has a property that each terminal is connected only to the next clockwise terminal. That is, port 1 is connected to port 2 only, but not connected to 3 and 4. And port 2 is connected to 3, not 1 and 4, and so on. So at that wise, in a clockwise, the circulator will be connected. So whenever the wave travels from one direction to in the opposite direction, there is no propagation. Whenever the signal travels from nth port to n plus 1th port and not in the opposite direction. So one see here, the wave is travels from nth port to n plus 1th port but not in the opposite direction. So actually microwave circulator is a multi-port microwave device. There is no restriction on the number of ports and it has a number of ports depending on the application. So but here we are using a 4-port circulator that is commonly used circulator here. They are useful in parametric amplifiers, tunnel diodes, microwave links, duplexers in the radar. So the main application of the circulator is the isolation of the transmitter and receivers connected to the same antenna, that is in radars and microwave links. So in radars also we use the circulator. So consider that 4-port circulator that is connected to the radar system. So here the port 3 is connected to the transmitter, whereas the port A is 1 is connected to the receiver. A common antenna for transmitter and receiver is connected to the port 2. The transmitted waves from the port 3 are circulated through port 2, which is connected to the antenna, while the received signals from the antenna circulated through the port 1 and gives to the receiver. The remaining port 4 is used for the measurement purpose. So in this way a common antenna is used with the help of the circulator. Okay. Next, need of directional coupler. So the microwave signals traveling through waveguide need to be analyzed in terms of the input power, coupling factor and directivity, etc. So the coupling factor is a measure of the ratio levels in the primary and secondary lines of the waveguide. So hence, if the coupling factor is known, the power at the input of the waveguide can be determined. So the directivity is a measure of how well the forward traveling wave in the primary waveguide couples only to a specific port of the secondary waveguide. So in order to determine these factors, the microwave signals must fed to the secondary waveguide while traveling through the primary. So in this regard, a directional coupler is used. So here the directional couplers are the transmission line devices that couples together two circuits in one direction, okay, while providing a great degree of isolation in the opposite direction. Okay, by using this, we will connect the two couplers in one direction, two circuits in one direction. It is a device used for the measurement of unidirectional power, standing wave ratio, and unidirectional wave launching. Next, a directional coupler is a four-port waveguide junction in which the portions of the forward and reverse traveling waves on the lines are separately coupled to two of the ports. It consists of a primary waveguide, that is a main waveguide. So see here, and secondary waveguide, that is a auxiliary waveguide. So here it is a basic directional coupler. It has a four-port waveguide junction. Here it has a four-port waveguide junction. It has a primary waveguides 1 and 2 and a secondary waveguides 3 and 4. When all ports are terminated in their characteristic impedance, there is a free transmission of the power without any reflection between the port 1 and 2. Yes, the degree of coupling between the port 1 and port 4 and between 2 and 4 depends on the structure of the coupler. Coupling factor can be measured at the port 4, may be used to determine the power input at the port 1. The power at port 3 specifies the directivity of the forward traveling wave. Okay, so this is about directional coupler. Thank you. Okay, so we'll close the session.